Hey everyone, welcome to our next video. Let me go over to our notes. This one is going to start 3.2. Which is verifying identities. So when it comes to verifying identities, really it's just a bunch of algebra. So what you'll do is you'll start with one side. This can depend like which side to start with. Sometimes it's just the more complicated side. Sometimes it's just the only side that it looks like we can do anything with. So that does depend. Next, we're going to always check for identities. And let me give us here our goal is to make one side look like the other. Really, the idea is, is to get like one side to be exactly the same as the other, because then they would be equal to each other. That's really what an identity is. So, like when we say stuff like sine squared plus cosine squared is equal to 1, this is an identity because we're saying no matter what you plug in as x, these things, if you square them and then add them, it would become 1. So when we're verifying an identity, what we're really trying to do is use identities and algebra to show that two sides are actually the same thing. So we'll check for identities, and then we'll use algebra. Then check for identities. So that's kind of like an always step. So like as you, I spelled that wrong. There we go. So as you are like looking for an identity to use, if there isn't one, we'll probably use some algebra, and then we'll see, okay, now can I use an identity? So you're kind of always looking for maybe an identity to pop out. Your last step, or like last case scenario, is if we don't have options, try changing into terms of sine and cosine. So that's kind of a last resort. Sometimes we'll do that pretty early in a problem, and sometimes we may not even need to do it at all. And then let's say you're done when both sides are the same. So let's just kind of start with an example and we'll just kind of go with it. So example 1, I'll say verify. And this one's going to be sine x plus 1 times sine x minus 1 equals negative cosine squared x. So really what we're saying is I'm telling you this is identity, but I need you to show me that these two sides are actually the same thing. And to do that, you'll start with one of the sides and then make it look like the other side. In this case, we can think about which side to start with. A lot of times, it's just whichever one you think you have an idea of what you can do. So, for instance, I see on my left side, this is kind of yelling at me, maybe I should FOIL it out. And so that's what I'm going to do. I'm going to start with my left-hand side. So I'm going to take my left-hand side equals. So I start off with sine x plus 1 times sine x minus 1. So I'm starting there. Then I want to try to FOIL this out. So if I do that, I'll get sine squared x minus sine x plus sine x minus 1. And I like to put my steps over on the side, so I FOILed or distribute, whatever you want to call it. Then I'll go ahead and simplify. And I just think that writing what you're doing over on the side can like really help you stay organized and make sure that what you're doing like makes sense. Now at this point, I have sine squared minus 1, and I'm supposed to be able to show that that equals negative cosine squared. So at this point, we have to do something a little creative. We're going to use an identity. Anytime you see a trig function squared and you see the number 1, you may be looking at one of the fundamental identities. So I'll remind you that we have this fundamental identity, I'll just say Fi, that sine squared plus cosine squared is equal to 1. And we've already proven that earlier in this class, so like we know that that is 100% true and that we can use that in anything we want. I can use that to replace this with something. So what I'm going to do is I'm going to make this look like I'm seeing sine squared x minus 1. So to do that, I'm going to move this 1 over to this side. So now I have sine squared x minus 1 plus cosine squared x equals 0. And I'm also going to move that cosine over. So now I get sine squared x minus 1 is equal to negative cosine squared x. So since this identity is something that we've already said is true, we're allowed to use it. So now instead of seeing sine squared x minus 1, I can say that this is equal to negative cosine squared. So I'm going to say this equals negative cosine squared x, and that was my right-hand side. So I'm done. And I usually like to put like a little, in math, often we use a little box during like proofs to say that we're finished. And so that's what I'm going to do here. That's how I'm going to say that I'm done. And I know that I'm done because I used algebra and identities to show that the left side is actually equal to the right side. Let's do another one. So example 2, say verify. And this one is 1 plus secant x times sine x times tangent x is equal to secant squared x. And so again, like I'm telling you that this is an identity. So we're just going to use algebra and also other identities to show that the left side is actually the same as the right side. Now again, for this one, I think it's a bit obvious like which side we should start on. Um, like I said earlier, a lot of times it is the more complicated side, but not always. So it's hard to just say all the time because there are instances where the easier side is actually where you start. So of course I want y'all to kind of think about this one and think about where you would want to start. But of course I'll tell you that we should start with our left-hand side. So again, I'm going to say my left-hand side, and I have 1 plus secant x times sine x times tangent x. And so I want to make this look like secant squared. Now this one doesn't really scream any like algebra steps to me. Like the other one, it was like FOIL. But this one, I feel like there's not really anything I can do. So this is one of the cases where changing into sine and cosine will actually be super helpful. So secant is 1 over cosine. Sine is already as simple as it can go, but remember I can write that over 1. And then tangent I can write as sine over cosine. So let's write what I did over here. I write in terms of sine and cosine because I didn't really have any other ideas. Like no identities really came out to me. Technically, this is using identities. It just may not feel like it. Then we can simplify. So if I multiply across, that gives me sine squared. If I multiply underneath, that gives me cosine squared. So here I simplified. Now you want to think, can I write sine squared over cosine squared as anything? And in this case, that would be tangent squared. So I used identity here. I used the fact that tangent is equal to sine over cosine. And again, we're not done until we get the other side exactly. Now, like I said earlier, if you see like a trig function squared and you see the number 1, you may be dealing with a fundamental identity. So in 3.1, I introduced this one to you. it was tangent squared x plus 1 is equal to secant squared. Now this one we can use like exactly. So tangent squared plus 1, that's what I have here, is equal to secant squared. So I can just replace it. And again, the reason we can just use that identity like freely, like just replace it in, is because we've already proved that it's true earlier in like the course. And that equals my right-hand side. So I'm done. Now I also want to point out for you that, as I'm doing these, of course I know where to go. While you are doing them, there's just some patterns that you should kind of look for. You see how this one had a 1 here and this one had secant squared? I feel like you can already start thinking based on that, I may need to use this fundamental identity. So it may like already kind of be in your mind of what you need to use. And so then when I got to sine squared over cosine squared, I was like, oh, perfect. That changes to tangent, and that's how I'm going to use the identity. So that's kind of the thought process that I come into these with. Is sometimes you can tell in the beginning, sometimes you can't. Sometimes you can't. It just, yeah, I mean, it's hard to say, but it depends. Example 3, just another one. This is really all we're doing in this section, is verifying. I'm just showing you a bunch of different ones that you could see. I will say that my math lab is a little hard to use for this because when it comes to the verifying, a lot of the questions are like multiple choice. So they kind of like tell you the steps to use, and that's really not a good way to learn how to do these problems. So I definitely recommend like writing them out on your own and trying to figure out, what would I do? And then you can kind of apply it to the homework problems. If you are, um, if you just kind of like go through the My Math Lab, I just don't think that that's a good example of how to do these by hand. Now, if you're watching this video, I'm just going to say this for future reference. This summer that I'm recording these videos is actually the last time that we are using My Math Lab. Later, we're moving to Alex, and so they actually have a different system when it comes to doing these types of problems, and I actually like theirs a little bit better. So that's just for future reference of these videos existing. Okay, so I go through this. Of course, I think it's good to think about which side you should start on first. This one is going to be the more complicated side. And the reason I know that is because what am I going to do with just cotangent squared? I guess I could write it as cosine over sine, but then how am I going to get cosine to look like cosecant minus sine? It's just harder to go from like one thing to multiple. Also, though, I do see this cotangent squared is kind of telling me maybe I'll use the identity that uses cotangent squared. So just a reminder, that fundamental identity is 1 plus cotangent squared x is equal to cosecant squared x. Sorry, I kind of ran out of room there. Let me write it better. So when I see that cotangent squared, I'm thinking maybe I might use that. I don't know for sure, but possibly. I'm going to start with my left-hand side. And we'll see what we can do. I want to warn you about something. If you're watching this and you're like, oh, let's just cancel out these signs, that is a big no. You cannot do that. What you're doing right there is you're undoing subtraction with division, but those are not opposite of each other. So you cannot do that. Also, if you try to do that, you're just going to be left with cosecant, and then you won't be able to get that to become cotangent squared. So, like if you do something algebraically illegal, it won't work. What we can do instead is we can split this fraction apart. So I can say cosecant x divided by sine minus sine x divided by sine. So I just split the fraction apart. And now I'm going to try to simplify. So let's see. I split up my fraction. And now I'm going to simplify. So of course, I mean, you should really pause these videos and try to like work ahead, like try to see if you can do them. Cosecant x over sine x. I'll leave that as it is for now. This is going to become a 1. And that's really good because my fundamental identity has a 1 and cotangent squared is over there. So that's kind of telling me like, maybe I'm going to use that identity. Now I need to simplify this cosecant over sine. Cosecant can be written as 1 over sine. So I'm going to replace that. So I'm going to replace cosecant with 1 over sine x. And this is still over sine x. And I have minus 1. So right here I used an identity. I used the fact that cosecant x is equal to 1 over sine x. Then, so remember when you divide, that's the same as multiplying by the reciprocal. So remember that anything that doesn't have a denominator is really over 1. So this is really sine over 1. So if I want to change this to multiplication, it would be 1 over sine x times, and then I'd flip the bottom fraction, so 1 over sine x. And then I still have this minus 1. So instead of dividing, I multiplied by the reciprocal. Keep going. We get 1 over sine squared x minus 1. So in here I simplified. One over sine squared is cosecant squared. So here I used an identity again. I actually used the same one that we used earlier, but now they're squared. And the reason it's okay for them to be squared is because there's no like plus or minus in there. Like the reason I bring that up is, for instance, like this identity, you can't use any other powers on it except for the squared because of this plus in there. But if it's just multiplication and division, the power doesn't matter in the identity. Like it just kind of follows through. Now I'm seeing that fundamental identity pop up. So the one that says cotangent squared x plus 1 equals cosecant squared x. I'm seeing that happen here because I expected it earlier. I want cotangent squared. I have a 1 and I have a cosecant squared, excuse me. But I need to make it look how I need it to. So I'm going to move over that 1 and it'll be cotangent squared is equal to cosecant squared x minus 1. So I can do it. I can replace cosecant squared x minus 1 is equal to cotangent squared x, which happens to be my right-hand side. So now I'm done. So this one was a little bit longer. But a good one to look at. I'm going to scroll up a little bit so you can see again. So cotangent squared is what I was trying to get, and that's what I ended up with at the end. So that's how I knew I was finished. I've also had people in the past like multiply both sides by sign or something like that, like basically treat it like an equation. That's not really a accepted way to verify identities. You want to really start with one side and just make it look like the other. For the next one, I actually have to do a little bit of algebra like review with you. So I'm gonna make a little note here. I want to remind you of something in algebra called the conjugate. And so the conjugate is used to simplify things. Often in algebra, it's introduced to you when trying to simplify square roots in the denominator. So I'll show you an example of how it's used. Let's say we have like 2 over 3 plus root 5, something like this. To get the radical out of the denominator, we would multiply by the conjugate, which would be 3 minus root 5. And as long as you multiply something on top and bottom, you're totally good to do it. You're just multiplying by 1, so you're not actually changing anything. What happens is we'll do 2 times 3 minus root 5 divided by 3 plus root 5 times 3 plus root 5, which gives me 6 minus 2 root 5 divided by, oh, I accidentally put a plus right there, sorry. This would be 9 minus 3 root 5 plus 3 root 5 minus 5. So this becomes 6 minus 2 root 5 over 4. And we could simplify this a little further technically because everything can divide by 2. So we could do 3 minus root 5 over 2. So what this is doing is our issue was the square root. So we multiplied by the conjugate, which all the conjugate does is switch the sign. That's all that it does. And the reason we did this was to be able to simplify. Something interesting is you don't have to multiply, like it doesn't have to be the denominator. It just has to be something with like a plus or minus in there, and then you multiply by like the opposite of that. So if it was a minus, you would multiply by the plus version. If it's a plus, you multiply by the minus version. But sometimes it's because of the numerator. Like the numerator, we decide to multiply by the conjugate. So I don't want you to get trapped into thinking that it's just always the denominator. And we will actually do an example of one where we do it because of the denominator, one where we do it because of the numerator. So let's go ahead to our next example. This is 4. I'm going to verify. This one says cosine alpha over 1 minus sine alpha equals 1 plus sine alpha over cosine alpha. Also, make sure that as you're writing these steps, make sure you don't like drop your angle or anything. You always want to keep that with the trig function. I never want to just start writing like cosine by itself or sine by itself. So for this one, we are going to use the conjugate, and I want to kind of hint you as to like why we would use it. So you see how both of these sides are kind of equally as difficult? It's not like one of them really looks worse than the other. Also, think about like what would happen. So if I were to multiply the left-hand side by the conjugate of this would be 1 plus sine alpha over 1 plus sine alpha. Well, I have a 1 plus sine alpha on this side, so it may help me out to kind of see that appear. So sometimes you got to kind of be thinking ahead. So I'm going to start with my left-hand side, which is cosine alpha over 1 minus sine alpha. And I'm going to multiply by the conjugate. Now, if you need more help understanding conjugates, I would definitely look up more videos on multiplying by conjugate. Remember, we live in a great time where the internet exists and there's a plethora of videos for you to look at to try to figure this stuff out. So the conjugate for this would be 1 plus sine alpha, but I gotta make sure I do it at the top and the bottom. So this would become, oh, I didn't mean to do that. This would become cosine alpha times 1 plus sine alpha divided by 1 minus sine alpha times 1 plus sine alpha. Now I'm going to distribute. This gives me cosine alpha plus, ooh, I kind of regret distributing, but I like that I did it, but I'm going to tell you why I regret it as well. It's because I lost sight of what I'm trying to get. So it's always good if you feel like you kind of did something that maybe doesn't help you out. It's no big deal. Just start that step over. And sometimes you'll notice that when you do these, that maybe you'll like start a certain pathway and it's just not helping you. You can always just restart. Don't get too like overwhelmed. So what I noticed here is when I distributed it, I was like, man, what am I going to do with cosine times sine? Well, it's because I really shouldn't have distributed, because this 1 plus sine matches what I'm trying to get to. So I really shouldn't distribute the top. So I'm going to go ahead and erase that step. And I'm just going to write it how it is earlier. So cosine alpha times 1 plus sine alpha. Because that looks more like what I'm trying to get to. I hope that makes sense. Now I am going to distribute out the bottom because I'm trying to make the bottom look like cosine. So these signs and stuff are not helping me at all. So that I am going to distribute. So I get 1 plus sine alpha minus sine alpha minus sine squared alpha. So I distribute the bottom. And we discussed why I don't want to distribute the top. I'm going to simplify. Cosine alpha times 1 plus sine alpha divided by 1 minus sine squared alpha. So here I just simplified. Now keep in mind, what are we trying to get to and what do we notice? So we've done a bunch of algebra. Let's check for identities. So I see the number 1 and I see a sine squared. This should definitely make you think of the fundamental identity. Also, you're trying to get cosine at the bottom. If this uses the fundamental identity, I can maybe get cosine out of that. So that's kind of where my mind is going. So I'm going to use the fundamental identity that says sine squared plus cosine squared equals 1. And I put x, but if you want to write alpha in there to make it more like what you're seeing, that's okay. If I move sine over to the other side, sine squared, I'll get cosine squared is equal to 1 minus sine squared. This tells me that I can replace this sine 1 minus sine squared. I can replace that with cosine squared. So that's what I'm going to do now. So I'll have cosine alpha times 1 plus sine alpha divided by, and this is now cosine squared alpha. Now we can simplify because cosine over cosine squared, one of these cosines can cancel. Now the reason you're allowed to cancel here and you couldn't like in that other problem I showed you is because right now you see how this is multiplication? So we're undoing multiplication with division. That's allowed. So this will become 1 plus sine alpha over cosine alpha. And that's exactly what I was trying to get. If I scroll back up, you can see that's the right-hand side. So this equals my right-hand side. So I am done. So I put my little box. And my last step here was I simplified. Hope that one was all right. Moving on to the next one. Example 5, and this is another like conjugate type. So verify, and this one says 1 minus sine squared t over 1 minus cosecant negative t is equal to 1 plus sine negative t divided by cosecant t. This one starts out with all these negative t's and stuff like that. So my first step is I would probably rewrite this whole problem, and I'd be okay with you doing this. I would rewrite this using even odd identities. So I'm going to rewrite using even odd identities. So I want to remind you from 3.1, odd functions are sine, cosecant, tangent, and cotangent. What that means is that the negative can come out to the front. Cosine and its secant are both even functions, so their negatives would just go away. So I would get 1 minus sine squared t divided by 1. Now this negative would come out to the front, so it would cancel with the negative that's already there. So this would become plus cosecant t is equal to 1 minus sine t over cosecant t. Now, in some instances, maybe we could just work with the negative on whatever side we pick and then just put it back in at the end or whatever. I personally don't mind you just rewriting it and starting with this problem. I think it's fine. Someone else, may have different opinions about that, but that's for their class. This one, again, I want us to think about like what we can do. They both look pretty equally complicated. And if I think about the conjugate, so I want to think about like what I can multiply by. If I do like this side, if I do the left side, and I do like 1 minus cosecant t over 1 minus cosecant t. Don't write this for a second. If I were to do that on both sides, it doesn't really seem like it helps me. You could always try it, but you'll find that it just starts to look more complicated and it just doesn't help. And that's okay to start a certain thing on a problem. And if you get to a point where you are just completely stuck and you're like, I don't even know what I would do with this, I feel like I'm even farther away from my goal, you may just need to restart and try something else. Now if I try on this side, if I multiply both sides by 1 plus sine t, I do like that it's going to give me what I need at the top. So that's what I'm going to go with. I'm going to multiply both sides. Sorry, not both sides. I don't know why I'm saying, I mean like top and bottom, but I'm saying both sides. I mean top and bottom, sorry. Because like if I had done the 1 plus cosecant or whatever, it just would have given me 1 minus cosecant squared, and that just doesn't look anything like the other side. So that's why I wouldn't try it. Hopefully that made sense. So for this one, it's our first one that we actually start on our right-hand side. So I start with 1 minus sine t over cosecant t. I'm going to multiply by the conjugate, so that would be 1 plus sine t over 1 plus sine t. And so this is one where like we're using the numerator for the conjugate instead of the denominator. Okay. Now I need to distribute and see what we need to do. I'm trying to get 1 plus cosecant t at the bottom. So I do think that distributing is going to be a good idea for this one. Also at the top, I think distributing would be a good idea. So first I'm going to rewrite it a little bit just to make it nicer. So sine t times 1 plus sine t divided by cosecant t times 1 plus sine t. And then I'm going to simplify this. So this would become 1 plus sine t minus sine t. So that'll go away. Minus sine squared t divided by cosecant t plus cosecant t times sine t. And so let me give you some ideas of like why I think we're on a good track. So right here I distributed. Like how do I even know that what I'm doing is being helpful? So if I simplify this, at the top I would get 1 minus sine squared t. Well, that's great. That's what I want, right? So I'm trying to get my left-hand side here. So the top is perfect. It's just the bottom we got to work on. But you see how I have a cosecant and then I have a plus. So I really just need to simplify this, the cosecant t times sine t. So that's how I feel like I'm on the right track. So divided by, and so let's see, I simplified the top. Now I'm going to work on the bottom as well because I need this little part right here to change. So I do know that cosecant t, it seems like what I'm missing is a 1. Well, I know that cosecant t is 1 over sine t. So let's try that. So I get plus, and then let's do 1 over sine t, and then that's times sine t. Remember that anything can be written over 1 if it doesn't have a denominator. So these are going to cancel. So I'll just be left with 1. So I end with 1 minus sine squared t over cosecant t plus 1. And we can check that is my left-hand side. So I put that here. I put that's my left-hand side. So I'm done. So I put a little box. Now, I'll be honest with you. I think this one is a hard one. I really do. I think some of the ones we've done, even already, like example 4, I think that one was pretty hard. You have to be creative with the algebra, and sometimes our algebra skills are a little, a little weak. Maybe it's been a while. I don't know. Whatever the case may be, I want you to know that I do understand that some of these are difficult. And just if you're needing any help, it may be a matter of just looking up extra videos, maybe looking up algebra help in general, or maybe reaching out to me and seeing if we need to, maybe I need to explain these with you, maybe one-on-one or something like that. So just let me know what you're needing and I will do my best. So I got one more for us. This one uses a slightly different algebra idea. So we're going to verify. This one is 2 tangent squared x is equal to 1 over cosecant x minus 1 minus 1 over cosecant x plus 1. This one I think you should think about which side we should start with. I think one side looks more complicated by like a lot. So we're going to start with that side. So for this one, we're going to start on our right-hand side, which is 1 over cosecant x minus 1 minus 1 over cosecant x plus 1. Something I notice is I'm trying to make multiple fractions become one like thing. So I really would like to combine these fractions. So I want to combine fractions. To do that, I need to get common denominators. So I need these denominators to be the same. The only thing that we could possibly do to make these denominators be the same would be to multiply this one by cosecant x plus 1 over cosecant x plus 1. Basically, I'm saying let's multiply each one by the other's denominator. And then on this side, I'll multiply by cosecant x minus 1 over cosecant x minus 1. Now I'm going to write this a bit nicer. So I have cosecant x plus 1 over cosecant x plus 1. And this is times 1 over cosecant x minus 1. So that's my one fraction, my first one. Now for my second one, I have 1 over cosecant x plus 1 times cosecant x minus 1 over cosecant x minus 1. So I multiplied this one by this one's denominator at top and bottom. And I multiplied this one by this one's denominator, top and bottom. And I'm doing this so that we can get common denominators. It's really no different than when I talk about like adding something like this together and you multiply this one by 2 over 2 and this one by 3 over 3. That way you can get a denominator of 6. It's really the same idea. It's just now we've got harder things to look at. Now, I'm thinking we should simplify as much as we can because I'm trying to get 2 tangent squared, like that does not have any cosecants in it at all. So I'm definitely thinking we should try to simplify as much as possible. So I'll do that. So at the top, I would have cosecant x plus 1 minus, and be careful here, use parentheses. This is cosecant x minus 1 because you want to subtract that whole thing over, and at the bottom I'm going to write our common denominator, which is cosecant x plus 1 times cosecant x minus 1. So all I did so far was write it as one fraction. So I write as one fraction. And we can do that because we got the denominators the same. Now I'll go ahead and distribute and all that. So let's see. I get cosecant x. I really do recommend you pausing and trying to do it on your own. But I'm going to do it. Plus 1 minus cosecant x plus 1 divided by, this becomes cosecant squared x minus cosecant x plus cosecant x minus 1. So I'm going to put a note here, I distributed, slash FOIL, whatever you want to call it. And next I'm going to simplify what I have left over. So at the top, the cosecants cancel, so I'm left with 1 plus 1, so it'll just be 2. And that's really great because if you look at my left-hand side, what I'm trying to get is a 2. So this one I feel like we had to do a good bit of work before we really start seeing our other side like come to life. But we just had to trust the algebra. At the bottom, I get cosecant squared x minus 1. So what I did here was I simplified. So next, I need cosecant squared minus 1 to somehow become tangent squared. Well, I see squareds, I see the number 1. Maybe let's try the fundamental identity. So I do have a fundamental identity that utilizes cosecant. It says 1 plus cotangent squared is equal to cosecant squared. If I make this look like what I have, I would just move this 1 over to give me cotangent squared is equal to cosecant squared minus 1. And this does help me because cotangent squared is at least getting us closer to tangent squared. So I'm going to replace cosecant minus 1 with cotangent. So this becomes 2 over cotangent squared. Now remember, cotangent squared would be, well, cotangent or whatever, it has an identity that relates to tangent. So I have another identity I can use. I know that cotangent is equal to 1 over tangent. And so if I just make these squared, I have the same result. So I'm going to use that identity. So I get 2 over 1 over tangent squared x. Now remember, when you divide, that's the same as multiplying by the reciprocal. So this is the same thing as saying 2 times tangent squared over 1, which is just 2 tangent squared. And that's what I wanted. That's my left-hand side if I scroll up. So this will become my left-hand side. So I'm done. So I'm going to put some notes here of what I did. So I multiplied by reciprocal. And that was instead of dividing. So let me put that too. Instead of dividing a fraction, we multiplied by reciprocal. And that was it, pretty much. I mean, we simplified, but that was all. So that's it. And that's it for 3.2. Again, I really can't stress enough to you that if you are having any trouble with these, go ahead and reach out to me. You're welcome to look for extra videos on your own as well. But if I can help you in any way, please let me know. So I hope y'all have a wonderful day, and thank you for being here.